Hi, this is Miss Makeup with KNOX News, and I have in the studio with me Maren Meredith, who is the resident seismologist. For those of you who don't know, a seismologist is one who studies earthquakes. She's going to tell us all about the earthquake we felt yesterday. Maren, could you tell us what caused the earthquake?
Plates.
What are plates?
The Earth is made up of three main parts. The core, the mantle, and the crust. The crust is broken up into tiny fractures called plates.
And what do these plates do?
Well, these plates float around on the semi-liquid mantle layer. Well, then as they bump, grind, or separate from one another, they cause earthquakes.
Well, that makes a lot of sense, but how does it actually make the earth shake?
Well, when the faults move, they release energy, and when the plates move, they release energy in the form of seismic waves.
Seismic waves? Now you said faults. What are faults exactly?
Well, they are the side of the plate.
All the boundaries, the edges around them? Those are the fault lines, basically. Interesting. So you said that they produce seismic waves.
Well, there are three kinds of waves.
Tell me more about them.
Well, the first kind is P waves. They go straight back and forth.
Oh, like that?
Yeah. And the second kind is S waves. They move side to side.
Oh, like that?
Yeah, and they're slower. And then there are surface waves. They move up and down.
The surface waves do that?
Yeah.
And what does that mean? How do you know which one is going to occur?
Oh, we can tell using a seismograph.
A seismograph? How interesting. Can you tell us about your seismograph?
Well, the seismograph tells us about the earthquakes because what you're saying is all these lines are how big the earthquake was.
So you're telling me that when there's an earthquake, it makes this thing shake and then it records it by using lines?
Yeah.
I see. So that's how it works. And when you were talking about P and S and surface waves, now they occur, how do you know which one is going to occur?
Well, how?
Different directions.
Well, when we can tell when the faults move in a different direction.
Oh, so depending on which way the faults move, as you said, with the boundaries of the plate,
Yeah.
then it will produce a certain kind of movement of the waves, right?
Yeah.
I see. That makes sense. So you're telling me that this will tell us the size of the earthquake. Now, how do you calculate size of an earthquake? What do you call that?
We call that the triangulation method.
The size.
Oh, the size? Oh, we can tell by the size of the lines.
Okay. So, but what do we call the size of an earthquake?
A what?
What do you call the size of an earthquake? For instance, you said that this earthquake was a 7.4. What does that mean?
Well, we measure earthquake based on the magnitude of energy it releases, which is determined by how much shaking it causes.
Oh, I see. So the size of the earthquake is the magnitude of the energy it releases?
Yep.
Now, you said something about triangulation. Can you tell me about triangulation? What does that mean?
Well, it's when we do beginning again.
So you were telling me that the distance, how do you know how far an earthquake is? You're saying that you use your seismograph, and what did your seismograph tell you?
It tells us
tell you how far away it is.
Well, remember when I told you that P waves are faster than S waves?
Yes, yes, you told me that S waves were slower than P waves, but that's the same thing, yes?
Well, we can find the difference of the time between the P and S wave, and when we figure it out, it tells us the distance of the earthquake.
How very interesting. And you were saying you use the triangular methods between 3 different seismographs to that location. Now, my understanding is what you're telling me is that we look here, you can tell how far an earthquake is, but you can't tell which direction it is in, right?
Right.
So it could be anywhere this far away from your seismograph, right?
Right.
So you said that, what do the 3 seismographs do?
Well, they tell how big an earthquake is, so
What did 3 of the seismographs do?
I forgot.
The triangulation you were talking about, how did they help us find the earthquake?
Well, where all 3 of the circles intersect, that point is called the epicenter.
Okay. So why do you need 3 circles to do that, to find it?
Because if we use 2 circles, there will be more than one epicenter. And if,
Oh, like I see right here or right here?
yeah,
But with 3, there's only one place where they all come together.
yeah,
I see. So basically you're using 3 points, like in a triangle, and that's why you call it the triangulation method?
yeah.
Interesting. So, but according to you, this earthquake was 7.4, which is pretty big as far as magnitude goes. Can that be dangerous?
Yes.
Tell me, how so?
Well, earthquakes can break roads and destroy buildings.
Really? Is that all they can do?
No, they can also cause mudslides and volcanic eruptions and tsunamis.
Oh my goodness. But there are ways to keep us safe, right?
Right.
Like what?
Well, one way is by building earthquake-safe buildings.
And how do you do that?
Well, we use these rubber. We use rubber. What's it called again?
Where do you put the rubber? You use rubber walls?
No.
Where does the rubber go?
It goes on the bottom of the building.
By the foundation?
Yeah.
So it's probably like on the joints, is what you're saying.
Yeah. And well, there's rubber joints on the bottom of the building
Uh-huh.
to slow down the vibration.
Very interesting. So do we have buildings like that here in Arizona?
No,
Uh-oh. Why not?
because it's far too much expensive and difficult to build them.
So we're doomed.
No, we're not. Take a look at our geological map.
What's on our geological map? What am I looking at?
You can see all our fault lines.
There doesn't appear to be very many of them.
That's because here in Arizona, they are mostly inactive.
They're mostly inactive. So you mean that earthquakes don't happen very often here?
Yeah.
Well, that's very reassuring to know. Thank you so much, Mary Meredith, for your time visiting the studio. And that is me again, Miss Makeup, with KNOX News. And back to you, Bob.